In this video, we'll look at the sum of two trigonometric expressions, or rather the value of a trigonometric function when you add things on the inside of it. So the basic form of things that we'll consider right now is something like, what is cos of x plus y, or sine of x minus y, or things of that form. So if we take two angles and we add them together, or subtract one from the other, and then take the trig function of it, what does this get? Now there are a bunch of identities for this, and I'll write them out in a moment, but the first thing that we need to get off the table is what this is not equal to. So a very common mistake is to say that this is equal to the cosine of x plus the cosine of y. And this is absolutely not true. Okay, so in a minute we'll look at an example of sort of why it's not true by just computing things. So first off, then let's just take what the identities are. And there are four of them, but we can actually write them as sort of just two of them if we're clever about our notation. So we'll take the cosines first, and the identity that I'm going to write is for an angle alpha plus or minus an angle beta. And these formulas I've always had difficulty memorizing, so you may you just look these up when you need them. That's what I do. And the identities are as follows. So we get cosine of one, cosine of the other, and then sine of the first and sine of the second. And now what goes in between is a little funny. So I've used this symbol once before, and I'm going to use it again, and it's the symbol minus plus. So that's different from plus or minus in that when this symbol is plus, that symbol should be minus. And when this symbol is minus, that one should be plus. So yeah, plus here would go with minus there, and minus here would go with plus here. So the point is that they're just opposite signs of one another. Yeah, okay. And for sine, S-I-N-E, the identities are as follows. Sine of alpha plus or minus beta. And this one's a little funny in a different way. Instead of having a minus plus, it also has plus minus. So that part is the same. But then what's different is that you get the sines and cosines mixed up here. So whereas in the first identity, cos went with cosine, here cos and sine go together, and then the other one is in the opposite order. So of course, in all of this, you got to be very careful to make sure you put the minus in the right spot, that you don't accidentally have the negative of what you're talking about. Okay, so let's take a quick example of one of these. Let's compute cosine of, and I'm going to work in degrees here just to make this a little bit more concrete, is let's compute whatever the cosine of 120 plus 45 degrees is. And when we do this, we're actually going to be exact. There'll be no decimals or any of that nonsense. One way that you might think is, oh, well, this is just 165 degrees, and then cosine of 165 is something. And at that point, you get stuck because 165 degrees is not a special angle on the unit circle. We have to think about it as 120 plus 45. But not to fret, because we have these nice identities. So because I've got a plus in here, I know my identity needs to have the minus, and then I just need to fill in the numbers. So we've got cos of the first one and cos of the second one, and then minus sine of each of them. And then we just need to compute all four of these terms on the right-hand side. Now the nice thing here is that each of these four terms are things off the unit circle. The cos and sine of 45, those are the easy ones. For that we just get root 2 over 2. And for this term we also get root 2 over 2. Then for the sine and the cosines we'll have to be a little bit more careful. So for that, let me note that 120 has a reference angle of 60 degrees, and that's because they add up to 180. So the sine of 60 is the same as the sine of 120 with a plus in front, and the minus is here is just from this minus. So sine of 120 is square root of 3 over 2, which is, by the way, the same as sine of 60. Cos of 120 is the same as cos of 60, except it's negative because we're in quadrant 2. And cos of 160, or excuse me, 60 degrees is 1/2, so the cos of 120 is minus 1/2. And so for this, we get negative square root of 2 over 4 minus square root of 6 over 4, and we can buddy those up as negative square root of 2 minus square root of 6 whole thing divided by 4. Now notice, by the way, that this answer is actually a negative number, and it should be because 165 degrees is still in quadrant 2, and in that quadrant cosine is negative. So it makes sense that the answer that we've got here is clearly negative because you've got a negative thing and you take away a positive thing, so that stays negative. And then yeah, and then the 4 is buddied up. So it was quite convenient here that we had common denominators already. We didn't have to mess with any of that. Okay, so the other example that we want to do here is just to convince you that, in fact, this identity is false. So let's sort of on the side separately compute what's cos of 120 plus cos of 145, or excuse me, 45. So if we had cos of 120 degrees plus cos of 45 degrees, then we said that this would be negative 1/2, and this one was, of course, square root of 2. Oops, that is the worst 2 on the planet. Square root of 2 on the over 2. And this number is clearly different from this number. In fact, this number here, if you think about it for a minute, the square root of 2 is actually bigger than 1. It's like 1.414, blah, 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 blah. So if you take away this 1/2 from this term is actually positive. And it shouldn't be positive if it's equal to cos of the sum, because 120 plus 45 degrees is in quadrant 2. This answer is clearly negative, and so we know that it's at least not totally ridiculous from the get-go. Okay, so do not ever make this mistake. You cannot just distribute cosine over the parentheses. It's a function, not a term that you're multiplying by. Okay, so just be careful and don't ever do this, and everything will be okay. And just remember not to botch the minuses here. So just be careful to look these things up off of the trig sheet, including, and these two formulas, by the way, are included on the yellow censored trigonometric sheet. So you don't have to memorize them, but you do need to know how to use them correctly.